This is adding and subtracting rational expressions. We just finished up with multiplying and dividing. Now we're going to look at adding and subtracting. I'm going to start with a couple of examples that we did back in the 6th grade or so. So this is a subtraction of fractions. In order to subtract fractions, you need a common denominator. In this case, the common denominator would be 12. I would get that by multiplying this by 2 and this by 2. And I would multiply this by 3 and this by 3, which is like multiplying by 1, 2 over 2, 3 over 3. That gets me 10 over 12 minus 3 over 12 equals 7 over 12, 7 twelfths. So that's how you subtract fractions. You have to have a common denominator. Let me do a couple examples for you. So here's 5/6 minus 1/3. I just want to show you that you don't always have to multiply both fractions to get a common denominator. In this case, I could just change this, multiply this by 2 and this by 2, and now I have 5/6 minus 2/6 equals 3/6 or a half. So I didn't have to change both denominators. So when you get a common denominator, sometimes you change both, sometimes you just change one of them, as long as you can get them to both be the same number. So here I made 12 and 12, here I made 6 and 6. Okay, and to generalize, if you had 1 over x minus 1 over y, and you wanted to subtract these two fractions, you would need a common denominator. This denominator has an x, we need a y. This denominator has a y, we need an x. 1 times y is y. 1 times x is x. The common denominator is xy. It's the same thing. Xy, yx. It's the same thing. They're being multiplied together. And so now I have y minus x over xy. And that's what the answer would be for fractions like this. Okay, so you can take what you learned in the 6th grade and you can generalize it with algebra. That's all algebra is generalizing things you did in arithmetic, elementary mathematics, and you generalize it using letters, and you do the same process just with letters. Okay, and you cannot subtract a y from an x. You just call it y minus x. Okay. All right, so now those are not the type we're going to be doing in class. That's just a review of some things, and now I'm going to show you the types of problems you'll see more like this. Let's do 7x over 15y squared plus y over 18xy. So I need a common denominator. Basically, this is like, instead of calling that 15, you could think of it as 3 times 5. 3 times 5, and this is 3 times 6. So this denominator needs a 6 because it doesn't have it. So I multiply this by 6 and this by 6. This one needs a 5. So I multiply this by 5 and this by 5. This denominator has 2 y's, or y times y, so I need an x somewhere in here. And this denominator has an xy, but I need 2 y's to match this one. So I'll put a y here and a y here. So the numerator now is 6 times 7 is 42x squared. This numerator is 5y squared, y times y, and I'm adding. And the common denominator, these denominators should be the same. 6 times 3 times 5, or 6 times 15 is 90. Same thing here, 6 times 3 times 5. And then you have xy squared, xy squared. So that's the common denominator. And I can't reduce this anymore, so that's the final answer. You cannot add these terms together because that's an x squared and that's a y squared, and you can't add unlike terms together. Okay, let me do 2 more examples. So let's look at this one. W plus 12 divided by 4w minus 16 minus w plus 4 over 2w minus 8. First thing I'll do is factor out a common factor out of here to see what my denominator looks like. So that's 4 times w minus 4. If if I factor out a common factor. And if I factor a 2 out of here, I get 2w minus 4. Nothing happens here. I haven't done anything yet. And now I'm looking at the denominators to see how can I make them common denominators. This has 4 times w minus 4. This has 2 minus. So if I double this, if I multiply this by 2 and this by 2, now I have 4 here, and the denominators match. So the common denominator is 4 w minus 4. And in the numerator, I have w plus 12. And this is like a negative 2 being distributed, so minus 2w minus 8. And if I combine like terms here, I get negative 2w and 1w is negative 1w. 12 minus 8 is 4. And it's tempting to cancel these. They're almost the same. If you factor a negative 1 out of this, then you will have w minus 4. Oops, I'm going off the video here. You'll have w minus 4 here, and you have 4 w minus 4, and these cancel, and so the final answer is negative 1/4. That's what it reduces to. Okay, so again, in case any of that got cut off here, I found the common denominator. All I had to do was multiply this by 2 to get it to match this one. So you're just trying to create common denominators, things that match on both sides. I distributed here, combined like terms, factored out a negative 1, and cancel these 2 terms. All right, one more example. Let's do this one. 1 over x minus 1 over y over 1 plus 1 over x. So that's a complex fraction, a fraction divided by a fraction. Instead of calling this x, 1, I can call it x over x. So now I have a common denominator. So I have x plus 1 over x. Over here I can get a common denominator, as I did this example earlier, times y times x times x. So now I've got y minus x over xy. And now I can do keep, change, flip here. So I can do y minus x over xy times the reciprocal of this, x plus y. And these x's cancel right here. And I'm left with y minus x over y times x plus 1. And that cannot reduce, resist the temptation to cancel these y's out. You cannot do that because this is y minus x is one term. Okay, so this is adding and subtracting rational expressions. The goal is to get a common denominator and then add and subtract.